other people to join. Let's give them a few more minutes. So just a brief history about IEEE. IEEE is a global organization that started off initially as a society for engineers only. But as time went by, they started accommodating other people. For instance, we have a society called HAC. We have sites that accommodates people from the humanitarian sector. So IEEE is like an umbrella that shields a lot of societies. For instance, we have IEEE PS, that is Power and Energy Society, that basically deals with matters power and energy in the electrical and electronics engineering field. And basically, our talk today is more geared towards that. And then we have IEEE ComSoc, that is Communication Society, that deals with matters communication, wireless, 5G, etc., etc. And then we have IEEE Computer Society. We have please just for housekeeping, as our speaker is speaking, just keep your mics on mute so that there is little feedback or no feedback at all. Yeah, that will enhance the quality of what you get. So as I was saying, we have like affinity groups. For instance, now that we are on Women in Engineering, it's one of the affinity groups. Like I had mentioned, not HAC is an affinity group that deals with the less fortunate in the society, HAC and SITE. And HAC is more business oriented, SITE is more on the humanitarian, where people come up with solutions to solve human problems, the less fortunate in the society. So Women in Engineering is an affinity group that advocates for more engineers, lady engineers, to come on field, to come on board. So it's where we are now. It's what I'm spearheading in KU. We have different chapters for we have in JQuat, we have in UN. Yeah, those are the ones that we have so far, or under Strathmore. So we normally have events. I remember the first event that we had was on tenacity of a lady engineer, which was held by Michelle Boyd, petroleum engineer. And today we have our speaker, Martha Wakoli, who is a renewable energy engineer. And apart from that, maybe what I forgot to mention was that the structure in IEEE is that it is a global organization in itself, and then it has regions. For instance, Kenya, we are in region 8, Europe and Asia also region 8, and then we have sections. Now countries are called sections. For instance, we have Kenya section, we have Uganda section, we have Malaysia section, Tunisia section, etc., etc. And then now we have branches. Branches constitute universities. For instance, now we have Kenyatta University branch, we have University of Nairobi branch, we have Moi University branch, we have JQuat branch, etc., etc. And then after that, now inside branches, we have chapters, chapters that are for societies. For instance, if you have a ComSoc society, it will be IEEE, ComSoc. So that is the hierarchy in IEEE. And unless anyone has any other question concerning IEEE, you can just feel free to speak. So in IEEE KU branch, our chairperson currently is Fidel Makatia. And then Now, inside it, like I said, we have women in engineering, and then in women in engineering, we have a few officials. For instance, I'm the chair. Then we have Masingulat as the vice chair. We have Christine Were as the secretary. We have Stella Chalagat as our web. Yeah, those are current officials. And then we have a lot of other volunteers inside. Does anyone have any other question? I think my time has run out, and our speaker is almost coming up. Let me introduce our speaker. Is a very able engineer. She's called Martha Wakoli. She has the Google Virunga Power. She has been working there as a renewable energy engineer, and she'll say more, but she has a lot of experience in renewable energy. She has worked in them. For instance, her recent project in West Pokot. She has a lot of experience, and trust me, you want to keep your ears inafaa utege masikio yani, little lack of a better word, but you should pay a lot of attention, because she has a lot in store to offer. And after this session, trust you me, you'll be having a lot of knowledge, despite being not exposed to the smart grid technology before. And just for housekeeping, as I had said earlier, as the speaker is going on, mute your mics. And as the sessions is going on, and if you have any question, you can just type it on the chat section. Type it on the chat section. And then after the talk, I will just review the questions, and then you'll be answered accordingly. But before the session is over, please put your mics on mute. And we are going to go from 6:10 to 6:40. And then after that, it's going to be a Q&A session. So allow me to welcome our guests on board. Welcome, Madam Martha Wakoli.
Thanks, Cynthia. Hi, everybody. First, no one calls me Madam. Just, just a disclaimer. I need to confirm, someone please chat or put your hand up. Can you hear me clearly before I proceed? Yes? Okay, good. So welcome all to today's webinar. Thank you for making the time, especially for those who are in the eastern parts of the world. It's evening. I'm sure you've been having a long day. So thank you very much for making time for this webinar. I'll start by introducing myself. My name is Martha Wakoli, as Cynthia earlier mentioned. I'm incredibly grateful to KU IEEE specifically for asking me to make some time to have a chat with them about smart grids and smart grid technology, largely because I've been working in the energy sector for about the last 5 years as an electrical engineer in different capacities that we'll talk about as we move along. I'd also like to thank the participants who've shown up. The premise upon which this discussion will be had will be a fairly technical premise. So because IEEE is an engineering society, then you will find the bulk of the material in the earlier stages as I am setting the context for what is a grid, so to speak, the traditional system that is a grid, so that with an understanding of that, a foundational knowledge of that, then we can discuss what is a smart grid, how can Kenya transition towards that, which steps have already been taken, what is left to do. So at this stage, I will try and share my screen. Again, I will request you to put a thumbs up or wave if you can see my screen at this point. Or one of you, can you see my screen clearly? And can Cynthia please unmute and let me know what you're seeing?
Yes, I can see your screen clearly.
Okay,
I can see your screen clearly.
All right, thanks. So we're going to dive right ahead into the presentation. As you can see, I've named it Emerging Technologies in Power and Energy, Smart Grid Technology. So as I mentioned, I have worked in electricity and electricity access as an engineer for the last 5 years. I also happen to have a background in electrical engineering, and power systems is my specialization. So this particular topic is very dear and interesting to me because this is what I research, this is what I work on. So this is typically what I enjoy talking about. So as Cynthia earlier mentioned, just some ground housekeeping rules, because again, technology and the virtual world and the idea of bandwidth, kindly switch off your video if you don't need to use it, as well as mute your microphones just so it minimizes feedback on my end. I'm generally a very animated speaker, so I've switched off my video so that I don't distract you with my hands and everything. But if you have any questions or comments that come to you as I move forward with this presentation, please feel free to put those in the chat box. Cynthia will moderate the Q&A right after this. I have about 16 slides and you're looking at the first one. So typically I have about 15 slides worth of material that I hope I can manage to go through in the next 20 or so minutes. So this is a webinar, not a class lecture. And therefore, you don't expect sort of an in-depth knowledge and understanding of the topic of smart grids, but I certainly hope to transmit a bit of an overview and a general knowledge for how it applies in our context, as well as recommended reading for where you can find more technical material on this subject and also more general material on this subject. So up until that point, I hope we're okay so that I can dive into the actual presentation itself, and we can start with the outline. So why does this matter? Why does grid networks or smart grids in general matter? And so how I've structured my presentation is in a way that the first 3 sections of the presentation, about the first 10 minutes, will be to provide a context. 1, to just introduce the idea of power systems, because I understand that this is a mixed audience. So we might have some engineering professionals, we might have some students, and then we might just have general audience who is curious about the power and energy sector. And so we'll have an introduction to power systems and why it matters. And then thereafter, I will move into a slightly more technical area, which is the definitions and the basic electric power concepts. Those are, I promise, the only 2 areas that have a lot of physics, math, and engineering. It's basic, but it is foundational. We need that to understand what I am talking about when I move on later to smart grids. And then after I have defined broadly power systems and electrical engineering, we'll move into the Kenyan context. What do we have today? What exists here? What do we use in Kenya? And then we can move on to smart grids, because then there'd be sort of like a transitional, coherent understanding of what it is, what is there today, and what we are hoping to achieve. And then thereafter, I will conclude my presentation and we can move on to the group discussion, which Cynthia will moderate, which is about the challenges and opportunities that exist in the power and energy sector today based off of our discussion. So to start, I'll go straight into the introduction. And basically, power systems are being adopted across the world, not just in Kenya, to address 3 main functions. 1 is energy security. The second one is affordability of the power itself. And the third one is sustainability. How do we generate this power without depleting our natural resources? So those are the 3 fundamental reasons why power systems is an issue of concern at all. Additionally, for many developing countries like Kenya, you will find only a small fraction of the population have actual access to grid electricity. So most people in rural areas, and I'd be interested to listening a bit on your perspective on this towards the end, most people in rural areas have self-generate, which means they might have a small solar panel on their roof that serves only their house, or are part of something called a microgrid, which is a small islanded system like what is shown in this picture that serves a couple of houses within a neighborhood, but is not necessarily connected to the national grid. So this matters because all countries are trying to solve this particular problem, but the problem is even heightened in countries like ours, where we have vast geographical coverage, but not everywhere has access to electricity. I'll move on to some of the definitions for things that I will be talking about today. This shouldn't worry you at all, even if you're not an engineering professional. It's just that as I use the words, it would be helpful to understand where I'm going with this information. So basically, when I reference the grid, I mean the electric network of transmission lines, substations, transformers that deliver electricity from the place where we generate it to your home or business. Typically, the grid has existed since the 18th century. There's a story about Edison, the 19th century, sorry. There's a story about Thomas Edison and him switching on the first grid in 1882 that you could very easily Google. But basically, the point there is the traditional grid and how it functions is something that has been there for over a decade, for over a century. And so that means there's a lot of experience and a lot of information available online, offline, in textbooks, etc., to just help you understand the very premise of power systems. And then the next two definitions are about transmission systems that we use in Kenya. So one is high voltage alternating current transmission. And this is conventionally the three-phase system we use to transmit power over a long distance. This is, if you travel towards Mombasa via road or towards Naivasha, you will see these massive steel structures that look like a Christmas tree without leaves. Those are called transmission pylons. And in Kenya, mostly, we use HVAC transmission. So you use 3 wires, alternating current transmission. However, as we are trying to move more and more power from one end of the country to another, we are now actually developing infrastructure for something called HVDC transmission, which is using direct current for bulk transmission of power over a longer distance. And this is actually helpful because HVDC systems tend to be less expensive and have lower electrical losses. On the electrical losses, I will explain that in the next slide, where I am talking about basic electric power concepts. But think about it in the same sense of a loss as in a business. You put in some money, but on the other end, what you get is not enough, or is not enough to cover for the money that you put in. Electrical losses work analogously the same way. And then what is a smart grid? I guess today's area of focus. It's basically an electricity network, or the grid that I told you has existed since the 19th century, but that has a layer of communication embedded into it, which allows suppliers and consumers to manage their demand, to protect this network, to save energy, and to reduce costs. So this will be the primary focus of our discussion today. Energy efficiency is basically the understanding of using less energy to perform the same task in order to eliminate energy waste. And why this matters is because this is one of the aspects that a smart grid looks at with regard to managing demand. A smart meter is possibly a term you have used but might not fully understand what it defines. A smart meter is a device that records information such as how much electricity you're consuming, the voltage levels, the current and power factor, especially for commercial customers, industrial customers who use active and reactive power. So those are some of the aspects that I'm saying might be a little technical if you're not an electrical engineering student, but given that this is a webinar, also just feel free to open a tab on your internet and search active, reactive power and those kinds of things. It will give you a broad understanding as we move along. So smart meters normally communicate this information to the consumer just so they understand where they can save some money, but also to the supplier of the electricity to allow them to monitor and bill these customers. And then lastly, in definitions, we have electric vehicles. It is hardly ever a situation where you will talk about smart grids without talking about e-mobility or electric vehicles. So basically, there are 2 types of EVs. There's EVs called all electric vehicles, and then there are others that are hybrid electric vehicles. So as the word states, all electric vehicles run purely on electricity, while the hybrid version can run on electricity, and then once the charge is finished, they switch over to an internal combustion engine, which runs on gas or fuel when the battery is depleted. So it's still more efficient than a regular internal combustion engine. So up till that point, I hope it's sort of clear where we are going with this discussion in terms of defining a baseline, just so people understand which words I will be using as we move forward, but also to then lead us into my next slide, which is basic electric power concepts. So in the practice of power systems, and this is largely targeted towards the students who are attending this webinar today, There are certain things that you probably learn in physics in Form 3 and 4 if you're a Kenyan student, or in your A levels if you do the other kind of system. However, those principles guide power systems and sort of network distribution. They're very basic principles. I'm sure many of you have heard of them. And the first one is the Ohm's law. This basically provides us with a relationship between power, voltage, current, and resistance, which are sort of like the four main parameters that are used in power systems. Why this matters is because it explains why we step up electricity to a high voltage in order to transmit it over a long distance. And the reason for that is covered under this area of P loss. We are trying to minimize loss by stepping up to a high enough voltage for the current to be very little, because the current is a squared function. And so if you have a lot of high current, you're having a lot of loss as your electricity is being moved from one place to another. That's one reason why it matters that we step up electricity to a high voltage to transmit it over a long distance. The other thing is then now the distance itself. The resistance varies directly with the length of the conductor. So if I'm moving electricity from Mombasa to Turkana, then it means the amount of resistance on that line is much higher than if I'm moving power from Mombasa to Lamu, which means the losses again on that line from Mombasa to Turkana will be much, much higher than the losses on a line from Mombasa to Lamu. Why does this matter? Because of how Kenya is shaped, how Kenya is structured, and I will explain that in my next 2 slides. So bear this in mind when I am talking about transmission and distribution and why certain decisions are made with regard to extension of the grid or the use of microgrids in certain areas. So in Kenya today, let me just stop there and find out. Can you still hear? Someone please put their hand up, just so I'm not talking to myself.
Yes, we can hear you.
Okay, great.
Yeah.
Loud and clear.
Cool, thank you. So in Kenya today, the power generation sources are as shown on the pie chart. The idea with the pie chart is to give you an indication of how much power we get from each different source. So it's not so much the numbers that you see in there, but the percentage, because it shows you, as it is today, the bulk of Kenya's electricity is generated from hydro and geothermal. So this was information from October 2019. This graph has shifted just slightly. There's slightly more geothermal that has been injected, as well as slightly more wind that has been injected between October 2019 and today. However, in terms of proportion, the pie chart still looks the same. So geothermal is taking a massive chunk, and that supplies Kenya with what is called base load. And then we have hydropower, which helps us with peak load or ramping, adjusting depending on the demand. It follows demand. And then you have wind, solar, and thermal or fossil. In case you're wondering why we have such a massive component of thermal power today on the grid, even though we have said that hydro and geothermal are our primary sources, it is because of the distance that I was talking about between Mombasa and Turkana, for instance, or between Nairobi and Suswa. So if you think about where your geothermal is generated, it is generated in the Rift Valley area, but it is required to be used everywhere, including Bamburi, which is at the coast. If you think about the bulk of our hydro, it comes from the Seven Forks scheme, which is along the Tana River, somewhere here near Mwingi, for those who might have had a chance to visit the Seven Forks scheme by KenGen. Again, if you imagine generating power here in Tana River and it requires to be used in Mandera, then you understand why we still have quite a bit of thermal power, because it is just cheaper to run a diesel generator in Mandera itself instead of transmitting electricity over 1,000-kilometer distance. So to just give you an understanding, Kenya's grid is mostly green from what you can see. However, not all the places where we generate the electricity is where we need it. And sometimes the cost of transmission is so high that it makes more sense to just generate locally where the plant is. I have been told I am dropping off the line. Has it come back before I continue? Sorry.
You're back.
Okay. Cool, thank you. Sorry for that technical hitch. So hopefully you caught what I was saying about generation and why we generate in certain areas but need the power in other areas. And that then brings us to the next slide, which is what our grid network looks like. So I hope you pay a bit of attention to the map on the right, the principal areas of supply, because in and of itself, it is very telling as to how much more work requires to be done, basically as a country and as an industry, to try and make this a little less disparate, as you can see now. If you look at the northern and northeastern parts of Kenya, just from the diagram, you see it is bare. And that bareness shows there's not much electrical transmission infrastructure in those areas. This isn't a very old map. This was a map from 2018. And so there are some adjustments that have been made. For instance, a line has now been extended to Garissa, as well as Lamu Island. However, beyond that, the rest of the parts that you see, north and northeastern, Isiolo, Samburu, Mandera, Wajir, Garissa, many parts of the north and northeastern areas are still bare without grid infrastructure. Another thing you see by looking at this map is that a lot of Kenya's electrical grid infrastructure is concentrated almost along the railway line. It's very similar to how our railway line moves. So it joins from coast to the port of Kisumu. So you think about it as just the southern part of Kenya can really claim it is electrified in that sense. The northern part, which is actually the larger portion of land, does not have electrical infrastructure. So in Kenya today, the typical transmission voltages are 220 kilovolts if you're moving power over a long distance, 132 kilovolts, 66 kilovolts, and 33 kilovolts. Why does this matter? Because as I said, we have to step up this power to these kinds of voltages to allow us to move the power from places where it is generated, like Seven Forks or Suswa, to the places where it needs to be used, like Nairobi or Thika or areas like that. However, there's a black line that you see going straight up towards Ethiopia. That's a planned HVDC transmission line, and it will be Kenya's first HVDC transmission line. And it's currently being set up by KETRAC.
Merudi.
Okay, so let me know, where did I drop off? Anybody?
You didn't drop off. I had everything.
Okay, all right, that's fine, thank you. Okay, so in which case, there's a black line going up towards Ethiopia. That line is showing us an HVDC line that is actually currently under construction by KETRACO, the transmission company owned by the government. So that will be Kenya's first HVDC line, and it is because it's covering such a long distance. As you can see, it's going all the way from Ethiopia. It's coming to interconnect in Suswa. That's over 700 kilometers worth of distance. So it needs to be at an extremely high voltage in order for the losses to be low. Additionally, it is DC so that they can use 2 lines instead of 4. So that saves on materials and makes it slightly cheaper. Now, typical distribution voltages, this is what you see normally in your estates, near your houses, poles and lines and wires. In Kenya are 11 kilovolts or 415 volts if you see 3 phases and 4 wires, or 240 volts, like what comes out of your socket. Normally what you use to charge your phone, what you use to power your TV, your fridge, that kind of thing. That is 240 volts. So, having said that, the reason Kenya relies heavily on HVAC, which is what I mentioned earlier, is because to allow us to operate at these varying voltage levels, we rely on step-up or step-down transformers. So as is, the traditional Kenyan grid, as you can see, is primarily HVAC, 2 is mostly concentrated in the southern parts of the country, and 3 is mostly fed by renewable sources, but the renewable sources are not necessarily spread out everywhere where the power is needed. Which then takes us to the next part. What makes a grid smart? So having described the traditional grid for what it is and how it operates with today's context in Kenya, then we think about what is a smart grid. So basically, a smart grid is just the digital technology that allows for communication between the grid and its customers, or for reactions along the transmission lines. That's what makes the grid smart. So if we have any form of automation on the grid, you're making your grid smart. Automation looks like many things. It could be a self-healing load break switch, for instance. If there is a fault on a line, the line goes off, you have a sensor that finds out where exactly the fault is. The rest of the line comes back on, and the portion with the fault is isolated and does not come back on. So that's one way of automation. Another way of automation is using smart meters. Having a meter that is intelligent enough to take readings at a customer's premise and send them back to you, whether it is via GSM, via mobile, via WiMAX, but send that information back to you so that your generator can adjust accordingly. Another one is an energy management system, for instance, where you have something that works like a CPU in a computer, pretty much, that determines how much wind you're going to use today versus how much solar versus how much geothermal versus how much diesel, etc., so that you have the mix of energy that is the cheapest at any given time. Those are just some examples of forms of automation that then make us say we are evolving towards a smart grid. So it's basically controls, computers, automation tech that works together with the electrical components of a grid to respond digitally, especially to the fact that demand changes all the time. So some of the sort of primary reasons why anyone would want to automate a system, not just the grid. One is to improve efficiency. So if power disappears, we want it to come back quickly, not to have an outage for 24 hours. You want to have an outage for 20 minutes. So it means if you have sensors along your line and these sensors are well coordinated, it means that then if you have automated portions of your line well enough that it is easy for you to diagnose where the problem is, isolate that problem, and restore electricity to the other consumers. Additionally, if you have customers who are generating, for instance, Strathmore University, they have a solar plant on top of their university that they use to generate power. So sometimes they use that power themselves, but sometimes they need to support, maybe KPLC, one of their plants is down, and Strathmore can sell the power to them. So in this way, a smart grid allows you to know which generation sources are available, which demand is required, and to balance those out in a way that is even and therefore efficient. So basically, having said that, the development of a smart grid, based off of the discussion we just had in the previous slide, is then a process. It is not a one-time event. It's not a single step, because every component of automation contributes towards what we would call a smart grid. So most of the times, you try and make your grid smarter because you're trying to optimize the behavior of your grid. Optimize in terms of make it cheaper, make it more reliable, make it more modern, make it more robust, those kinds of things. And so the diagram that you can see there on your right, I feel like is an easy explanation for all the interfaces that exist when you're trying to automate a grid to a point where you can say it is fully smart. So there are portions of monitoring and control on the generation and transmission side, or transmission enhancement applications that are already in existence and have been in existence for years. But then there are other newer portions like advanced metering infrastructure, electric vehicle charging infrastructure, customer-based systems that are currently being investigated, and people are innovating around those in order to make the grid as it exists today even smarter. So if you think about it that way, then does Kenya have a smart grid? The simple answer is yes. But how smart is Kenya's grid is then what we are going to discuss moving forward, because I'd be very interested in hearing your feedback on which are the aspects of the grid that you think should be automated next or quicker. So in the context of the national utility, in the context of KPLC, they have already automated their controls and monitoring. They use a system called SCADA or SCADA, Supervisory Control and Data Acquisition. I'm sure you guys have heard of it, especially for the students who are in school. For smaller companies, SCADA might be too heavy a program. So there are smaller packages for grid automation, especially for mini grids and microgrids, which takes me to my next slide. So if you look at the next slide on energy management systems, then if you think about that area that I showed you, especially in north and northeastern parts of the country where the grid has not yet arrived, but those areas run on diesel generators or small solar microgrids that are islanded and still need to deliver electricity reliably and affordably. So most of those systems are automated using something called an energy management system, which basically optimizes the behavior of the grid. It responds to the demand on the grid by balancing out the resources available in that area. So if it is solar PV, if it is wind, if you have some battery storage, diesel generators, whatever kind of mix of energy sources you have, then you have an energy management system, which then is supposed to help you manage reliability and cost, and also the efficiency of operation for the supply company, so that you spend less money to generate this electricity, which means eventually you can charge the people using this electricity less over time. Another aspect of smart grids that is currently being used actually in Kenya by the government is this thing called demand side management. When I was doing definitions a little earlier, I talked about energy efficiency and smart meters. So energy efficiency basically is how do we use less energy to do the same tasks? And that matters because it means we reduce the demand for energy on the receiver's end, which means we have to buy less generally from the generator. Additionally, if you have things like smart meters, it means consumers themselves can then take charge of their consumption patterns. And so they are more aware of which things they need to switch off, when they need to switch those things off, and those kinds of things to help you manage the burden on the grid. So what you see in the picture, because I guess smart meters seem like this mythical thing that are far, far away, but they're actually being used in Kenya and have been used here since, I believe, 2016. Yeah, we have smart meters. The one you're seeing there is actually a KPLC smart meter for a large power customer, or what we call a three-phase customer, like an industry or a big building. They have three-phase power connections and they have smart meters. These smart meters have a SIM card in them, and they also can measure things like voltage, current, power factor. And every 15 seconds, these units log this information and transmit it to KPLC. There's also a platform where these customers can log in and see their consumption patterns over time. So this helps them to balance their phases, to spend less money, to know where they can save. With regard to energy efficiency, this has actually been regulated by law in Kenya. There are certain rules and guidelines, especially for large power consumers, on energy efficiency standards that they must maintain. So the graphic basically shows you some of the ways that you can think about improving energy efficiency in a building or in an industry, and how to compare them with regard to cost versus impact. Another aspect of smart grids, and it will be the last aspect of smart grids I highlight today that is happening in Kenya, as you can see from the number plate of that car, is e-mobility. So electric vehicles basically, and their success is linked to smart grid development, because the charging infrastructure required for an electric vehicle is basically a precondition. You can't have an electric vehicle if you don't have charging ports. That's the simple way to explain it. So what is required then in Kenya is how much more power do we need to avail, or how many more places do we need to improve on to make this a reality. At the moment, the concept of e-mobility in Kenya is at a testing phase. So transport, and it's being tested. Why? Transport is one of the main sources of air pollution. Kenya is trying to adhere to these rules and guidelines for environmental concerns because climate change is a real threat everywhere in the world. So fuel consumption, burning dirty diesel, petrol, kerosene, might not be something that is sustainable over the long run. And so e-mobility is one of the things we have to think seriously about in terms of, if Kenya does transition to electric vehicles or electric buses or electric trains, then how do we avail the infrastructure required for them to be able to, for the transport sector to be able to fully move towards e-mobility? So based off of all those things I've talked about above, it seems pretty obvious that there are some aspects of the smart grid that are already A, in place in Kenya, B, being considered and researched, C, being financed to actually happen in the country. However, there are still some aspects that have not been completely figured out in terms of how do we make this cheap for everyone? How do we ensure the people in Wajir and Mandera enjoy the same quality of electricity as a person in Ruaka, Roysambu, Athi River, or Nairobi, Westlands, Kileleshwa? How do we ensure that we don't have power blackouts every time it rains? How do we ensure that when we do have a power blackout, it does not last for 14 hours, it only lasts for 15 minutes? So those kinds of problems are actively being sort of thought about, and solutions are being developed for those, both in the private sector and in the public sector. So as I conclude, I'd just like to go through a few benefits of a smart grid based off of the explanation I provided above on what is a smart grid, what is traditionally the grid, and why should we be thinking critically about moving towards a smart grid. So some of the benefits I've already discussed. One is the self-healing capabilities. This means the grid can automatically detect and respond to problems. So this means you recover faster after a disturbance or after a fault. The second one is if you automate a large portion of your grid, you reduce the operation and management costs. You reduce the number of people who are going out all the time to find out where the fault is because you have a sensor in place of a person. Which means if we can reduce the number of people, you can reduce the wage bill, you can reduce the cost of supplying this electricity to consumers. The other thing is called flattening the peak. If you can use your energy management system to respond properly to your demand, it means you can have a flatter peak instead of just one massive peak where we have to switch on all our generators at the same time. And when we do that, that's very expensive. So the flatter the peak overall, the lower your electricity cost. And then you can also increase now the integration of renewable energy systems. This is particularly important in Kenya, where we have a 310 megawatt wind power station in Turkana. We have a 50 megawatt solar park in Garissa. There's another 100 megawatt wind plant coming up called Kipeto. There's another 50 megawatt one by Frontier. There are all these solar and wind plants coming up. And you see, wind and solar electricity is only available when the sun is shining or when the wind is blowing. When those two things are not happening, it means you must have storage, which is either these massive battery packs, or if you don't have storage, then you must have a very intelligent system, a smart system that responds quickly to the changes in wind and solar availability with regard to your demand. So if you have a smart grid, it means you can increase the integration of things like large-scale wind and large-scale solar onto your existing grid. And then you can also integrate better customer owner power generation systems. This is what I was talking about with regard to Strathmore University, which means Strathmore in some cases are a consumer of grid power. In some cases, they are a generator to the grid power, depending on the systems. And then finally, if you have a smart grid, an automated grid, one that you can control and monitor properly, it means you have improved grid security. You can see everything. I use see in quotes because you have sensors just about everywhere. You can see everything, and therefore you can react to everything in good time. So having said that, I would recommend that in your spare time, you go through these links. They just talk about, they give a bit of insight in terms of like generation, diesel, this idea of solar plants, and then IEEE itself, since that's the host for this particular webinar today, IEEE has an entire platform called IEEE Smart Grid that's full of resources, technical material, tools that you can use to really discover more about this area of learning. So I think that marks the end of my chat. As I conclude, I just wanted to point out at the beginning, Cynthia mentioned she's a member of IEEE and she's the current chair for something called Women in Engineering. So I accepted the invite today for a variety of reasons. One, I'm usually very excited to talk to students. They're some of my favorite audience. But also, additionally, I'm very interested in the idea of normalizing the fact that there are very many female engineers in the field, and we need many, many more. As I've shown you, the whole of North and Northeastern is just bare. So we need more engineers, boys and girls alike. We need all your contributions. And so to that end, as you may have seen in the poster, I edit something called Co-Engineers, which I've put links here for you guys to check out. But it's basically a consolidation, a collection of stories from female engineers talking about their work and the things they're interested in doing and some of their experiences that I highly recommend you go and look for. Yeah, and so on that note, I will stop there and hand over back to Cynthia. I went a little overboard because the material was a lot and I realized too late after I had started, but I hope you found some of that insightful. And what are these called? The slides will be shared by Cynthia. There's a PDF version that she'll share with you in the event that you'd like to go through some of the material already mentioned. Yeah, so thank you for listening to me. Thank you for your attention. I will now mute my microphone. I'm very interested in listening to your thoughts on like smart grids. Why aren't we adopting them faster? What do you think are the contributions students and other people in the field can make so that we have like an interesting discussion? So I'll hand over back to Cynthia. Thank you.
Thank you so much, Madam Martha, for the interesting chat and conversation and talk on smart grids. Trust you me, I've learned so much about smart grid technology and about how far we are as in Kenya as a nation. Thank you so much for that. And without further ado, are there any other questions or comments? If you have a question or comment, just raise your hand and then unmute your mic. But allow me to first acknowledge that you are the one speaking so that you don't speak two at a time. So yeah, if you have a question. Any questions? Questions? Okay, let me just check at the chat section. We have a question, this goes to Madam Martha, by Cinderella Wafula, one lady called Cinderella Wafula. She's asking, how can young Kenyans take advantage of the smart grid and create entrepreneurial ventures out of it? How can young Kenyans take advantage of the smart grid and create entrepreneurial ventures out of it? Madam Martha.
Okay, so I'll take that. Thanks, Cinderella, for your question. Cinderella asked two questions. One, how can young Kenyans take advantage of the smart grid? The other, what are the features of a smart grid that have been implemented in other places that are not here yet? So the first one, in terms of how can you take advantage of the smart grid, I will refer to that map that I showed that has plenty of areas that are yet, one, to just get access, two, to have access that is affordable and reliable. So in my view, there's many entrepreneurial opportunities there. The first could be just collecting the data that is required in order for people to design solutions for those areas. So research and data analysis is one of the most helpful things that we don't do enough of. The other is thinking of solutions. So people have already started selling, let's say, solar home systems and things like that. That's one of the ways to think about it, but that's a very small scale way to think. If you think about mini grids, then it provides you with a broader spectrum in terms of how then can you create, let's say, prepaid meters, because you're engineering students, for instance, which prepaid meters are robust enough to withstand the heat in Garissa and Mandera, but still provide adequate enough readings without the coil getting, destroyed. So that's another thing. If you can come up with a meter that can survive the heat in those kinds of areas, you have latched onto an idea that will probably make you billions. Another thing to think about is also the infrastructure itself. The lines, the poles, the wires, they're built by people. And so if you can build the skill to be a lineman or woman to be able to string together conductors and insulators and provide electricity, if you can get training for solar T1, T2, T3, so that you can be setting up solar panels in areas that don't have power, then that's another way that you can create an entrepreneurial venture out of it. So there are many ways to think about this, not just as the user of electricity, but also as a contributor, an active contributor to this space. And I think there are many other options. I might not have all the time to sort of go through them, but off the top of my head, those are the three that I can think of. In answer to the question for what are some of the smart grid features that have been implemented in other places that are not in Kenya? One, domestic smart metering. So we have smart metering in the sense of for commercial customers. Industries like Bamburi or Mombasa Cement or the airport today have smart meters. If you walk around Nairobi, especially the CBD, you might see a meter like the one I displayed in the picture in a mabati cover. So smart meters in Kenya have been rolled out, but mostly for industrial customers. We have not yet reached the level where smart meters have been rolled out for domestic customers like you and I. That's one. Another is electric vehicle charging and support. So most of the electric vehicles that exist in Kenya today, most of the people charge them from ports that are in their domestic premises. They are not sort of like government provided outside the way you go to a petrol station. So those are some of those features of a smart grid that have been implemented in other places. If you read about Sweden or Finland, or even parts of the US with Tesla, then you will see there are certain aspects of grid automation that are ahead than where we are in Kenya today. Yeah. I don't know if that answers your question, Cinderella.
It does. Thank you so much.
Michael.
Daniel Kabugi has a question. What do you think will be the contribution of 5G in smart grid actualization and commercialization? The contribution of 5G in smart grid actualization and commercialization.
That's a great question, Daniel, especially because the slide where I was talking about what makes a grid smart, and the only word I underlined there was the digital technology. So the wider the bandwidth and the faster the networks that we have to transmit information on, the quicker we can automate many of the processes on the grid. So think about it like this. If I want to send information from Lake Turkana wind plant to the National Control Center, which today is in Dandora. Those are the facts. The National Control Center for Kenya for electricity is somewhere in Dandora in a place called Molem. Then it means if Lake Turkana require urgent response in terms of the sensors have seen something, it needs to come to national control so that then a reactive action can be taken. If we have 5G internet, for instance, it means that information will be transmitted in a matter of milliseconds, and that means the reaction time will be just as quick. So there'll be a massive contribution of 5G in terms of if we improve the telecommunications infrastructure, it means we are widening the capabilities for automating the grid. So that's a good question. Daniel also had another question in terms of what are the current challenges in smart grid implementation in Kenya. The first and I guess most obvious one is cost. We have an existing grid. You guys already complain electricity is so expensive. Now imagine adding automation onto that and we have to pass on the cost to the consumer. So if you think about that, one of the biggest limitation is actually the cost of implementing these things in a way that is still affordable for the citizens. The other challenge you might find with smart grid implementation, and I'll provide the example of energy management systems. So you can buy off-the-shelf energy management systems that have already been prepared by someone and you come and plug them in and they optimize. But you see some of the conditions in some of the areas where we live and work. It's extremely dusty, it's extremely hot, it's extremely remote, the network might not be so good. So you find your energy management system, the way it was designed to operate in the States, might not necessarily adapt very well to operating here. So you need to customize it for working in Kenya. So one of the current challenges is we still import a lot of our technology. We don't do a lot of building local technology. And that's one of the things I would encourage you people to do, especially KU and your ventilator building and that kind of thing. It's very impressive, but it's also very encouraging because if we combine the curiosity and knowledge with an understanding of the context, we are more likely to develop solutions that are more robust and more suitable for our context. I hope that answers Daniel's questions.
Someone, Derek has a question. Derek Ngigi. You have a question. Go ahead. Just unmute your mic and ask a question.
So my question to Martha is how about electrical vehicles. What is the future of electrical vehicles in Kenya, and are Kenyans going to embrace it, or we going really to setting up maybe an electric car company in Kenya? Is it a business perspective, or we are still far? That's my question.
Derek, that's a good question and an interesting one. So I'll answer it in parts. In terms of what is the prospect for electric vehicles in Kenya, I think the honest answer is it is an inevitable eventuality. It might just take long to get here, but it is an inevitable way that we have to think of going. So that means in terms of a business perspective, the early, what are they called? The early birds, or like the early adopters, might actually have an edge in this industry. I say that because at the end of the presentation that I made today, hopefully you will get a chance to look at it. Towards the end of it, there's a story about electric taxis and Drive Electric. The two companies that I know have started early adoption of electric vehicles in Kenya. Please go check them out and read about them. But basically, my point is, at the moment, our infrastructure might not necessarily be accommodating electric vehicles, but without a doubt, over the next 5 to 10 years, you will see a very distinct shift in how we think about electric vehicles and how they're going to be, how the infrastructure is going to be laid out to accommodate them. That's one. In terms of, are we still far? I think far is relative because, for instance, I've said the grid has existed since the 19th century, and only about 10 years ago did this concept of smart grids start picking up pace. Automation has always existed, but the idea of automating the grid only became like a serious consideration about 10 years ago. So you can imagine it took us about 200 years to think of automating the grid. So if you ask me, 5 to 10 years is not that long a time. So I don't think we are far. I think it's just part of the process. I don't know if that's a satisfactory answer, but those are my thoughts on that issue.
Oh, yes, thank you very much. So I can start a company of electric vehicles in Kosa.
Yeah, I would suggest you, before you start your company, you check out what the other two are doing and see if you can contribute your efforts there. There's no need for us to have 4 companies that all collapse. It might make more sense to actually collaborate with the people who already have some insight and have started doing the work.
Okay.
Yeah.
Thank you.
You're welcome. All right, guys, it's 7 p.m. Unless someone else has another question, I think I have kept you here for long enough.
Any other question?
Hello, I have a question. I don't know if anyone can hear me.
Yeah.
Hello, I'm trying to find. Hello.
Go ahead, Clarice. Go ahead.
Okay, thank you. I was trying to find the raising hand thing, but I couldn't. Anyway, my question is when you're talking about, for instance, when she said that, if, for instance, you're transferring electricity from Mombasa to Turkana it's not cost effective and all. So I was just asking, when you're looking at places like Turkana, Garissa, I don't know, I just wanted to know, a place like Nairobi, even if you start supplying electricity, you know that people will be using it on a massive level, and you get back what you input in terms of finances. But I'm not sure if that's the case for other places in Kenya which still have deprived supply for electricity. And so I wanted to ask, like, don't you think we should also consider how, like, what we input financially, if we'll get it back before we actually go out there to, let's say, supply electricity in Turkana?
Okay. So that's an interesting question. Thanks, Clarice, for your question, and thanks for joining. Clarice is actually someone I know. So microgrids, the concept of extending the grid towards areas that are so far and therefore expensive, vis-a-vis us first recovering our money, financial sustainability, before we look into those areas. So there's 2 ways to think about this. One, the citizens in Turkana, Garissa, Mandera, Wajir, Samburu, Isiolo, and Marsabit pay as much tax as you do. So just in terms of ethical behavior, they deserve as much electricity as the rest of us in Nairobi. So that's one way to think about it. The government's only priority cannot be to return investment. The second response, however, and it's an important issue you raise, is an issue of affordability. I mean, if even in Nairobi, we are complaining that electricity is so expensive. Can you imagine what would be the cost of just supplying 5 manyatas in Marsabit? It is extremely expensive because you don't benefit from economies of scale. And so what happens in situations like those, and this is something I would encourage all of you to go and check, is that the government normally gets grants or subsidies from places like the World Bank, African Development Bank, things like those, so that it subsidizes the cost of extending your grid through projects like Last Mile Electrification Project or something called Kenya Off-Grid Solar Access Project. So if you Google those two, Last Mile or COSAP, it will give you an indication of how are governments dealing with the fact that so many places are so far and still so unelectrified, in a way that is ethical, so that we don't overcharge the citizens of those areas simply because they are far, but also in a way that is fair. If you think about it, especially in the context of COVID-19, now that every county needs a ventilator, how do ventilators work without electricity? Now that children are supposed to be doing online learning, how do they do online learning without electricity? How do they charge the devices to learn online? How are the cell towers going to get the power they need so that these children can access bundles? So if you think about it like that, it is more than just a technical question with regard to electricity and electricity access. It is an issue of balancing both national security priorities, ethics, and the technical aspects. I don't know if that answers your question.
Yes, please. Thank you.
Do you have any other question? Any other question?
Yes, I do have a question. Hello, can anyone hear me?
Yeah, support. Go ahead and ask your question, support.
Okay. My name is Cynthia. So I have a question that caught my attention. So I wanted to know for Martha, when you said we don't have infrastructure for electric vehicles, as I was thinking about it, or even the past few days, I thought probably if anyone can install an EV charging port in their house, and now say for example you've had your electric car and you have that charging station, how does that prevent you from, or how is that I don't get the connection between what I've explained and lack of infrastructure. The only place I would say is probably there'll be lack of development for public EV charging stations. But if anyone has their own personal car and they can be able to probably pay an installer to install their own home EV charging port, I believe there's market for that. What do you think?
Thanks. You said your name is Cynthia. I don't want to call you support.
Okay,
Thanks
yeah.
thanks for the question, Cynthia. And that is actually correct. Your understanding of like EVs and sort of private EV charging is correct. And that's what I meant by on the slide where I'm talking about e-mobility. In fact, the example I have there is of someone who has an electric vehicle and their own private charging port. You're correct. What I was referencing, however, in the case of smart grids, as I also to allude to Clarice's question, is the idea of infrastructure is that infrastructure in and of itself is an enabler. It is not the end in itself. And so having public EV points is one, signaling to the market that Kenya is ready to have electric vehicle charging, but also it divorces the idea of a person having a private sort of charging station. So think about electric vehicles in the sense of buses or in the sense of trains, e-mobility in that sense. Shared infrastructure, shared public transport that would therefore require, let me call it a dedicated or like open public charging points. But in terms of, yes, as a business idea, EVs at the moment are working in this country because some people can afford to install charging ports in their homes, and it actually saves them money. One of the interviews I watched said someone uses about 24 units of power on their EV, which is actually cheaper than how much fuel I put in my car for a day. So if you think about it that way, then it makes sense. Yes, the EV market is ready and evolving, but for it to be largely acceptable and also for the cost of the EV itself to come down, there have to be big enough volumes, more people wanting the thing, so that the price can become affordable for more Kenyan citizens.
Okay, understood. Thank you so much. Very elaborate.
Thanks.
Thank you.
I have one question, if you allow me.
Okay, go ahead.
Could I ask? Okay, Mother, thank you very much for the wonderful presentation. It's an eye-opener and really gives an insight of what's happening currently. But listening to everything and the engagement that we are having, it actually comes out that research has a lot to do with this, and there's a lot of contribution that we need to get from the academia. So I just wanted to find out from the industry and the way you are working now, what is the link between the government, the academia, and the industry, so that all this can be realized within the expected timelines?
That's such a wonderful question. Thank you for asking it. So first, as not a representative of the government or private sector, I just happen to have experience in both sectors. One, I would say from my time at KPLC, Kenya Power had a program at their well, it used to be called training school when I was there. I think now it is called Institute for Energy Something and Research, the one in Ruaraka. And one of the aspects that they're doing today is they're actually recruiting people to go in, not just as like frontline engineers, sort of operations and management, but they're recruiting engineers to go in as researchers. That's one. The second one is what we are attempting to do today, IEEE, societies in universities, which was also my experience when I was a university student in a public university in Kenya. Societies in universities tend to expose students to a lot of opportunities to contribute. Students and staff, actually, let me correct that, students and staff to a lot of opportunities to contribute towards emerging issues, and in that way, almost force the hand of government and private sector to pay attention. So for instance, TIBAVENT, which I'll allow one of the KU students to talk about once I am done. The idea that there was a problem, everyone was thinking about a solution, but academia, because they have like labs and students and innovation, were actually some of the earliest people to come up with a low-cost ventilator solution for this country. I think in a similar way, there's a bit of interface between governments and especially the Kenyan government. They have this program called NACOSTI. I think NACOSTI has a heavy focus on science and technology researchers. On KPLC's end, I think there's that Institute for Energy and Research in Ruaraka. For KU, because this is the second time I'm speaking with KU, I think they're very strong societies and they try to have an interface with industry. The last time I spoke to KU, I was with Schneider and another company. And so I think in that way, there's a bit of muscle and collaboration, and it should be more, especially if you think of Strathmore University. I think their Energy and Research Center has made some significant contributions if you think of off-grid solar, coming up with standards for devices and appliances. There's an organization called CLASP that is an American NGO that finances a lot of research in the Kenyan energy space as well. So it is a valid point. I agree there should be much more collaboration and contribution from academia, but off the top of my head, I think those are the areas that I think of where some of this information can be channeled. And yes, you're right, a lot of our progress is heavily dependent on how much locally generated research we fund and do. That's true.
Thank you. That's well captured. Thank you.
Hello. Yeah. So, can you hear me? Hello?
Yes, I can hear you, Chris. Go ahead, Chris Murray.
So, my name is Chris Muremi. I am from Mo University. So, my question, first, I read that a smart grid is a system that has the ability of all elements of the electrical system to communicate with each other. That brings the concept of having elements in a system that are IoT based. That will named say data centers. So we say today I develop a meter that can send data to a data center. Is there any data center that is there currently for these purposes, or we are beginning from a starting level? That's my question.
Thanks, Moremi. So just off the top of my head, data centers have existed in Kenya for a very long time. I'll give you the example of KPLC because that's where I have a specific example. There's a data center in a place called Musaga. Musaga is in Western Kenya somewhere. You can Google it, but there's a data center in Musaga. But to answer your question, is the telecoms infrastructure mature enough for us to automate the grid? Yes. In fact, in Kenya, the telecom infrastructure is fairly robust. And so essentially what happens is we use data centers for the government as a backbone, but also you have private data centers like for Kenya Data Networks and things like that. They don't use all the cores for their fiber. And so you can route your traffic also through private data centers at a fee. However, to answer your question, yes, the government, KPLC specifically, let me put it that way. I know KPLC specifically has data centers. There's one in Mombasa, there's one in Musaga, and I believe there's a data center in Nairobi at Dandora, the control center where there's SCADA, somewhere in Dandora. So there might be more than those, but off the top of my head, those are the three I can remember. So yes, they exist.
Okay, thank you.
So we don't leave anyone else out. Is there anyone else with a question?
I have another question on the matter you talked about, the smart grid and 5G. I do think that will require the integration of fiber and fiber connections to those places. My question is, how do you integrate both the two, the connection to fiber cables and providing affordable electricity to places where it's less available?
Thank you for that question. I'm not sure who asked it, so I don't have your name, but thanks thanks for the question.
It is Cinderella.
Okay, Cinderella, great. So that's an interesting question, and it's also one of those things I'm really proud to report today. So if you look at your transmission lines, there are two things I will suggest that you go and Google and read about. One is something called OPGW, which is a fiber optic cable that runs along your transmission lines in Kenya today. And the other one is something called ADSS, all dielectric something support, which is fiber optic that runs on your distribution networks in Kenya today. Again, one of the massive advantages of having worked at KPLC was to actually see these things in real time. And so today, as we speak, how the SCADA network is supported in this country, how we are able to monitor Rabai station from Dandora, how we are able to monitor power coming in from Uganda, from Dandora, is because we have fiber optic lines running on top of your transmission pylons. So what you will see is 3 lines that are used for electricity, but at the very top, there is an earth wire that also works as a fiber optic cable. So it's a shielded cable that runs from end to end. So in answer to your question, the fiber optic infrastructure already mostly exists. In terms of expansion, as you said, affordability then becomes the issue. Expanding power lines by themselves is expensive. Now you can imagine expanding power lines and fiber optic infrastructure. That's what I meant by government has to think about it in terms of subsidies, or even in terms of taxing areas that generate more revenue higher, so that then they can use a bit of that money to extend these services to areas that have otherwise not been reached. So in some situations, we use power line communication, WiMAX, but that's very rare nowadays. Most of the communication now is done on fiber. I don't know if that answers your question, Cinderella. Does that help?
That helps a lot, but I also have another question. Students who are learning renewable energy, I know of a course at my university, Multimedia University. What would you recommend for them to learn on their extra time? Because there are instances where people learn in school, but whatever they've learned is not applicable in the real world. Recommend for them to learn on their own.
I'm not sure I caught your whole question because you were breaking up. You were asking people who have learned renewable energy what their course is not applicable. Please just say that again.
I think our question is, what will you suggest?
What they can learn on their own.
Okay. What things can university students learn generally? First, just general disclaimer. There is nothing you learn that is not applicable or that is useless. I can just say that now as a person who is old enough to know that as a fact. Everything you learn is useful even when you cannot immediately identify what it is useful for. Having said that, if you have spare time, what are some of the skills I think you should try and pick up? The first and probably most obvious one for an electrical engineering student is coding. Try and learn a programming language, not for the value of the language itself, but because coding teaches you a very specific way to think about problems, and it is a very helpful thing to know how to do generally as you navigate life. The other thing I would encourage people to learn more about, I guess, is the Internet of Things. One of you alluded to it. Learn about emerging technology. It is useful, not just the Internet of Things in what it means or like how it is used in other countries, but practical real-time applications for some of this technology you hear about that seems so far away. For instance, with smart grids, a lot of people reference developed countries. You think of smart grids and you think of Tesla, you think of smart grids and you think of Finland and Nokia, but you never actually think the grid that you have in your country is smart, just needs to be smarter. So I think an understanding, I may have mentioned this already, a combination of curiosity and an understanding of the context allows you to develop solutions that are appropriate and also very easily adaptable. So that's a good business model. That's a very good business model if you think about it. So I would suggest coding. Learn to code if you can, just because of how it teaches you to think about algorithms. And also spend some time learning about emerging stuff, 3D printing, smart grids, Internet of Things, that kind of thing. I would suggest you spend some time looking through those kinds of things. Yeah.
Okay, time is far much spent. I hope I'm not leaving anyone out. Yeah, so thank you so much, Madam Martha. In most of the advertisements, you will see that there is a LinkedIn link to them. So you can just click on it and then you will see that the qualifications of our speaker are quite epic. Yeah, so thank you so much, Madam Martha, for making time out for us to learn. As I said earlier, I've learned so much. I'm pretty sure that everyone here has learned so much, so much. And the mere interaction is a translator. So thank you so much. And allow me to speak about our upcoming engineering festival. It's going to be wonderful. It's going to be great. It's going to be a collection of keynotes, panel discussions, and workshops. So after that, you're going to be completely transformed. Yeah, because trust you me, the sessions that are going to be there, you're going to learn. And they're diverse. If you're an electrical engineering student or a professional, if you're a petroleum engineering student or a professional, biomedical, civil engineering student, etc., you're catered for. The keynotes that are going to be there are going to be awesome. So it's a session you don't want to miss. And thank you so much for attending these sessions. And once again, thank you, Madam Martha. Allow me to...
Thank you for having me. I don't know if you can still hear me, but anyway, thank you for having me. I had a wonderful time having a chat with you. I hope you guys continue with the same spirit that you're having, sort of taking initiative, being outgoing, trying new things, trying to engage with industry. It pays off in the end, so be patient. But also, work hard, which is super important. All of this is meaningless if you don't actually complete your engineering degree, which is the primary focus. So use all these things that you're learning to make, I guess, your learning, to enrich your learning experience. But thanks very much for inviting me and for having me today. Thanks.
Thank you. If in case you need if you need the slides or you need the PDF, reach out to me. Else I will share it in our IEEE KU branch group and the WE section group. So if you need it, please get back to me. I will post my email here and then you can get back to me. So allow me to end the meeting. Thank you so much for attending and have a lovely evening.
Thank you.
Thank you for having us.
Hi, Cynthia?
Yes, ma.
I'm seeing people asking, Martha has not posted anything here. Please just put the thing on the